Hello, so here we have a differential equation, dy by dx plus py equals q. So in this video, we're going to prove that the general solution to this differential equation, this first order differential equation, is e to the integral of p dx y is equal to the integral of e to the integral p dx q dx plus c, and p and q are functions of x. Okay, so let's get started. So this is our differential equation. Now if we multiply both sides of the differential equation by some function of x, let's call it f of x. So we get f of x dy by dx plus f of x py is equal to f of x q. Alright, multiply both sides by f of x. Now we do this so we can implement the product rule. Okay, so the product rule, okay, is given by the derivative of f of x y, okay, and this is equal to f of x dy by dx plus the derivative of f of x multiplied by y. So this is the product rule, okay, and this is our differential equation multiplied by some function of x, f of x. So that should be quite clear by now. Right, so if we compare the sides of these two equations, so what we're going to do first is compare the left-hand sides, and once you've done that, we can then compare these sides as well. So the left-hand side to the right-hand side, and then this right-hand side to the left-hand side. So let's compare this with this first. So by doing that, we can get f of x. So f of x dy by dx plus f of x py, okay, will be equivalent to this side here, f of x dy by dx plus f prime of x y. Okay, so just comparing these two equations. So if you don't see already, these are exactly the same on both sides, so they can cancel out. So what we're left with is this very simple equation in which f of x py is equal to the derivative of f of x, f prime x, multiplied by y. Okay, so by comparing this side with this side, we've gotten this equation. So if we solve for p, well, first of all, we know the y's cancel out. So therefore, we get p is equal to the derivative of fx divided by f of x. That's quite neat. So therefore, we can integrate both sides. And when we do so, we get the integral of p dx, which sounds familiar from the solution, which is equal to the integral of f prime of x divided by f of x dx. Now, from your basic calculus, you may be familiar with this structure of an integral. This is a type of integral, okay? And for any function of fx, if the integral of the derivative of f of x divided by f of x, okay, if you have that structure, then it's always equal to the natural log of f of x. Okay, and we add c. So what we can do then, now we know that, we can find the integral of p dx in a more simple way. We have the natural log of f of x is equal to the integral of p dx, but we're not finished there quite yet. We have a natural log function. Now, by one of the rules of our logs, if you raise this to the power of the base, so if you raise this to the power of the base. So the base of the natural log is e. So raise both sides of the equation, okay, above e. We know that this undoes the natural log function. So what we get is f of x is equal to e to the power p dx. Okay? And this is what is known as our integrating factor. E to the integral p dx is called the integrating factor. Okay, and we've just proved that by simply comparing these two sides of the equation. So what we're going to do now is compare these two sides, f of xq, with the left-hand side of the product rule. Okay? So, if we do that, I'll write it out again. So we have, so the left-hand side of our product rule, d by dx of f of xy, okay, we compare it to the right-hand side of our differential equation, which is f of xq. Okay. Now, integrate both sides. We're going to get f of x, y, okay, is equal to the integral of f of x, q, dx. Just integrate both sides. Integrate the derivative that cancels it out. Now, we know what f of x is, don't we? If you remember that f of x, our integrating factor, is equal to e to the integral p dx. So by knowing this, we can substitute f of x into this equation. And that gives us our general solution that we saw earlier in the video. So what we get is substitute f of x into this equation. We're going to get e to the integral p dx times y, okay, is equal to the integral of f of x, so it's equal to the integral of e to the integral p dx, multiplied by q dx, and then plus c. And there you have it, we've just proved the general solution to our differential equation, dy by dx plus py equals q, where p and q are functions of x. Thanks for watching.